this is Britt Kessel with another example video. In today's video, I'm covering example 5 from lesson 6-5 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to evaluate logarithmic expressions by changing the base. So, what I'm going to do here is I'm going to walk you through this process, and then we'll do some examples where we convert to base 10 as well. Okay. So it says, how can you use base 10 logarithms to evaluate base 2 logarithms? So the first thing that we're doing here is we are multiplying by the number 1. All right. Now remember, this number 1 looks a little funny. Okay, we're calling it the log of 2 divided by the log of 2. Remember, multiplying by 1 doesn't actually do anything. It doesn't change the value of the expression, it just makes it a little uglier. And so then what we're doing here is now they're using the power property to pull that log 2 of 3 into the logarithm. So that we have log 2 to the power of log base 2 of 3. And remember, whenever you have a number and a logarithm with that same base as the exponent, they cancel each other out, leaving you with whatever's on the inside. So because these cancel out, this turns into the log of 3 divided by the log of 2. And so what they did was they approximated each answer or each logarithm. So they said the log of 3 was about 4.77 and the log of 2 is about 3.01 or 0.301. And when they divided that, they got even more, about 1.585. So this is how they go about changing the base, and this is why the change of base formula works. Now, to be honest, from my opinion, the change of base formula is a bit archaic. This comes from the fact that calculators when we were younger used to only have a base 10 mode. They didn't have other logarithmic bases in them. And so we're going to go through and use this change of base formula here in the try it, but understand most calculators now no longer need the change of base formula. So here we go. So to use the change of base, all that you do is we're going to split this logarithm into 2 logarithms. And I get to choose whatever base I want for these logarithms. In this case, I'm making it a common log because that's kind of what they want us to do. But I could pick whatever I want. I could pick the letter E and turn that into a natural log if I want. It's my life, don't judge me. All right? Now, the old base that we have, the base 2 down here, this turns into log base 10 of 2. And the old kind of guts of the log here, the 7, turns into the new guts up here. And so I could go through and I could actually use a calculator. I'll do it on the side here. I could use a calculator to figure out these approximations. So for example, the log of 7 is 0.845-ish, right? That's an approximation. Should use swirly squiggles right there, right? Not full squiggles like that. Because it's an approximation, we're rounding these. Okay. Now the log of 2 is 0.301. And so if I actually do 0.845 divided by 0.301, I get about 2.807. So what I don't like about this is I'm rounding, and I'm using these rounded numbers to create another number which I'm also rounding. So the precision on this really isn't so hot. Okay? Let's try it here. So again, I'm going to create 2 logs on top of each other. I'm choosing log base 10 because I'm pretending like my calculator isn't that advanced. Alright, the guts of the old logarithm are the guts of the top of the log. The old base become the guts of the bottom log. And so now I'm doing these approximations. So the logarithm of 3 is about 4.77. And the logarithm of 5 is about 0.699. So together, 0.477 divided by 0.699 is about 0.682. So there we have it, guys. That is how to evaluate by changing the base. Until next time.